Hi, this is Mr.M.Raj, Department of Pharmaceutics, having 14 years of experience, qualified in GATE, GPAT 2010, Dean of Academics, MyPar. Now I am going to discuss about the states of matter, part 2. In part 1, we discussed about what is meant by solid, liquid, gas, plasma state, condensate state, and what will be the interconversions and what are the major concepts in it. Yeah, what we discussed means in the first part one, we discussed about vapor pressure, latent heat, liquid complexes, and eutectic mixes. Now we are going to discuss about liquid crystals, glassy state, which are very important. So intermediate state, supercritical fluids also an important intermediate state, which is not there in the syllabus of physical pharmacy, pharmaceutics one. So now we are going to discuss about what is meant by liquid crystals and what is meant by glassy state in this video. Yeah. So from first we are going to discuss about the liquid crystals. So liquid crystals is a mesophase between a liquid and a solid phase. Liquid crystals is a mesophase between the liquid and a solid phase. So what is meant by mesophase? Mesophase means it's an intermediate phase. Mesophase means it's an intermediate. Intermediate means in between the two phases. One is the liquid phase and second one is the solid phase. The intermediate between these two phases is called as mesophase. So in that mesophase, the liquid crystals can be formed, having a chances to form a liquid crystal. So there are different types of liquid crystals. One is pneumatic or thread-like liquid crystals. Second one is mactic, soap-like or grease-like liquid crystals. And third one is cholesteric liquid crystal phase. So comes to pneumatic. Pneumatic means which is thread-like liquid crystals. So the molecules are parallel arranged. Molecules are parallel arranged. Rotations are restricted. So look at here, it is a pneumatic phase. So these molecules are parallelly arranged, but the rotations are restricted, which cannot be rotated. The molecules cannot be rotated, which is restricted. So which is closed with each other. So such a type of liquid crystal is called pneumatic crystals or thread, which is having a thread-like structures. So it is having three these are mobile in three directions. It can be moved in three directions but rotated about only one axis. It can rotate about only one axis, but it can move in three directions. That is what about the pneumatic or thread like liquid crystals. Then comes to smectic or soap like or grease like liquid crystals. The molecules are arranged in layers. So in first parallel arrangement and in smectic arranged in layers with their axis essential normal to the plane of layers. So which is used for solubilization of water insoluble drugs. So what is the use of this smectic liquid crystals? Means if it is a insoluble in water actually, then we can use this smectic liquid crystals to improve its solubility. Insoluble drugs can be improved and nothing but the solubilization in water will be increases. So which is looking to be having a layers. Look at here, it is a smectic, all are properly arranged as a layers. So in pneumatic, these molecules are not arranged properly but parallel with each other, which having a restriction to move. So here they can move, which is arranged in a parallel way, then it's called symmetric. So which is having there are mobile in two direction, which can move in two direction. In pneumatic, which can move in three directions. Rotate about in only one axis. It's also a rotate about in one axis. So what is the difference between these two? Means mobile in two directions. This can move in two directions, magnetic. But pneumatic can move in three directions. So That is what about the difference between pneumatic and smectic phases. Then third one is holistic liquid crystal phase. Holistic liquid crystal phase is in a combination of pneumatic and smectic type. All are arranged in parallel at the same time in layer. If it is a parallelly arranged and it is a layered, then we can call it as a holistic phase. So all the liquid crystals, and there are three types of liquid crystal. One is a pneumatic, smectic, and cholesteric. So this is a small information regarding the liquid crystals. We should learn this. Then comes to, yeah, now we discuss about glassy state. What is meant by a glassy state? Glassy state is a type of solid matter which is transparent, non-conducting, and specific. It is transparent, non-conducting, and specific. So the glassy state can be formed while crystallization actually. So nothing but what is meant by crystallization, formation of a solid is nothing but a crystallization. So during crystallization, what actually happens means during crystallization, normally concentrated solutions are cooled slowly. Important point is. So normally concentrated solution cooled slowly. Then what happens? The finally solid will be formed by arranging of the molecules properly in a particular three spatial dimensions. So at a point, melting point, the particles forms crystalline material in which the unit cells are extended to all three spatial dimensions. Because of that reason, proper solid with a particular shape will be formed. That is called as a crystallization. So if the same crystallization is carried out very quickly below the melting point in a liquid state, very quickly below the melting point in a liquid state, then what happens? Do not have an opportunity to the molecules to align orderly fashion, unable to align orderly fashion during crystallization. Who? Molecules are unable to arrange in an orderly fashion. So if it is arranged in orderly fashion, the solid will be found, proper solid or crystal will be found. If it is unable to form a proper arrangement, then even the solid will be found but having a very less stability, having a brittly nature. So that is called as glassy state. Even it is a solid, but it is having both characters. So not molecules are not arranged in a proper manner, orderly manner. Because of that reason, we can call it as a glassy state. So the atoms are highly disordered, and such solids are called as glassy solids. So which is very important. Then comes to what is meant by transition temperature. So transition temperature is the temperature at which there is an absorption or release of energy as the temperature is lowered or raised. Nothing but what is meant by transition temperature, where the transition will take place from one phase to some other place. So that such temperature maybe because of releasing of energy or because of absorption of energy, whatever. If some substances absorbs energy and converts into other phase, in some substances release energy and converts into some other phase. So maybe absorption, maybe release of energy. The temperature at which this will be happened may be lowered or raised, and such temperature is called as a transition temperature. Let us see. So what happens if it is a below transition temperature? Below transition temperature, the polymer chains are frozen and the polymer is glassy and brittle. So if you want to get a glassy state, we have to make it below transition temperature. The polymer chains are frozen and the polymers are glassy or brittle in nature actually. So above, what happens above the transition temperature? Above the transition temperature, polymer chains becomes rubber in state. So above the transition temperature, the polymer chains becomes a rubber in state. Below the transition temperature, the polymer chains are frozen and will be having a glassy and brittle nature. This is what a simple description about the glassy state. So more than this will be there in the level 2 and level 3 studies. So if you want to learn more, you have to learn level 2 and level 3 studies, which is very useful. So thank you. For customized coaching, please contact Mr. M. Raj Kumar, Department of Pharmaceutics, Dean of Academics, MyPar, my number 8121337080. So, if you like this video, please subscribe, and part 3 will be coming soon. So, wish you all the best. Thank you.